Hello students, today we will learn about chemical reactions and equations. What are chemical reactions? Actually, in our everyday life, chemical reactions are occurring everywhere. These reactions are accompanied by a chemical change, which are usually irreversible. They are in the form of chemical changes, and you must have seen that when we leave milk out on the table in summer days, it spoils. The taste changes and a new substance is formed. Butter turns rancid. Food, when it gets digested, a new substance is formed. Iron, when exposed to air, forms rust. Rust is different from the reactant. Here, rust is iron oxide, which is different from iron. Copper, when exposed to moist air, forms a green deposit. This green deposit, which you had learnt in class 8, is a mixture of copper hydroxide and copper carbonate. Burning of a candle is an example of a chemical change. You will see that the candle gets used up. The candle is made of hydrogen and carbon. This burns to form new substances, which are carbon dioxide and water vapor. The candle burns to form a new substance. Burning of paper is also another example of a chemical change. And here a reaction is occurring. The paper is made of cellulose, carbon, hydrogen and oxygen, and this is going to get burnt and it will form a new substance. The burnt paper is entirely different from the paper which was not burnt earlier. Now, all of the above examples or the mentioned are chemical changes. New substances are formed. The new substances formed are products which are entirely different from the reactants. So, chemical changes are accompanied by new changes. So, generally we can say a chemical reaction, two or more substances, they chemically react to form one or more new substances. Chemical reactions are written in the form of chemical equations, just like we have in maths. As we balance equations in maths, also here we are going to balance the equation in chemistry, and this is based on the law of conservation of mass, which we will discuss a little later. Coal burning in air, carbon reacting with oxygen forming carbon dioxide. Carbon and oxygen, which are written on the left hand side, are reactants, and carbon dioxide is a product which is written on the right hand side. Magnesium, when it is made to burn in air, forms a new substance. The magnesium is a metal, it is burnt in air and it forms a new substance. For this we would require magnesium ribbon of 2 centimeters long, pair of tongs, sandpaper and a Bunsen burner. Now the magnesium ribbon of say 2 centimeters long is first rubbed with sandpaper, then it will be held in the flame with the help of a pair of tongs. It is seen that a white powder is going to be formed. Magnesium burns with a dazzling white flame and new substance formed is of magnesium oxide, which is a white powder. We can write a word equation, magnesium reacting with oxygen forming magnesium oxide. Then we can write the symbols in order to write a chemical equation. But just simply writing a chemical equation will not complete the task. We have to balance it. We will start by writing the number of magnesium and oxygen atoms both on the left hand side and on the right hand side. Here we will see that we can balance by first placing 2 in front of magnesium oxide in order to balance the number of oxygen atoms. Then we will balance the number of magnesium atoms by placing a 2 in front of Mg. So the equation will be written as 2Mg plus O2 forming 2MgO. Magnesium and oxygen are reactants and magnesium oxide is a product. Similarly, lead nitrate solution is made to react with potassium iodide solution. It forms a new product which is lead iodide. The above reaction is unbalanced and we have to balance it. So we will start by balancing lead nitrate, potassium iodide reacting to form lead iodide and potassium nitrate. So we are going to balance the equation by writing the number of atoms on both the sides. We can see that only potassium and lead are being balanced. For this, we will place 2 in front of potassium nitrate. Then we will again balance the number of lead, nitrogen, oxygen, potassium and iodine. We can see that lead, nitrogen and oxygen all are same on both left hand side and right hand side, but Ki remains unbalanced. For this we will have to place 2 in front of potassium iodide. Now we can see that the whole equation is being balanced. Lead is going to be 1 on each side, nitrogen 2, oxygen 6, potassium 2 and iodine 2. So the equation is now balanced. Before I start this is a equation showing when zinc is made to react with sulfuric acid, it forms zinc sulfate and hydrogen gas is evolved. Simply we can make the use of a chemical equation writing Zn plus H2SO4 forming ZnSO4 plus H2. We can see that the number of zinc atoms on both the sides is 1, hydrogen is 2 on each side, and the sulfur is 1 and oxygen is 4. So the equation is balanced. As we can see in each case, new substances are being formed. New substance in the first case was magnesium oxide. New substance in the second case was a precipitate of lead iodide, and in the third case zinc sulfate and hydrogen. So all of the above are chemical changes in which the chemical equations are going to be used to represent. So thank you.